from 5 to 6. But we are going to stick around for some time for additional questions. If folks do have anything that they'd like to ask, we would love to hear from you, and we'll be sticking around until I think 6:30. And then at 6:30, we'll probably all be ready for our dinners as well. So we'll be signing off and continuing on with the evening. But we are recording this meeting, and we are also live streaming. Attendees, we can't see you, we can't hear you, which means that you can be doing whatever you want on the other side of the screen, but also means that we're going to be using the Q&A function at the bottom of your screen. I'm going to talk a little bit more about that in a second. If you somehow managed to go through the last 9 or 10 months without using Zoom, you can find that button on the bottom, on my screen, it's on the bottom of my window, and it says Q&A, and that'll be the primary way that we hear from you this evening. So take a look at that and familiarize yourself with the Q&A function as we go ahead and get started. And we'll look forward to hearing your questions, your comments. We are going to have a presentation, so you'll be hearing from our panelists, who I'll introduce in a moment, and I will be moderating your questions this evening. If we have some low moments, I've got some questions in my back pocket, and we can always go back to talking more about Mike Pullen's cruise ship musical, but maybe not in the hour that we're focusing on bridges, something for later. All right, so let's go ahead and get started. Can we go to the next slide, please? All right, so this is what our meeting is going to look like this evening. The big question that we're looking at today is, what could the future Burnside Bridge look and feel like? We're going to be giving you a project overview and then looking at the background of a bunch of different bridge types. If you are curious about bridges, or have maybe dabbled in bridges or seen some of the other bridges around Portland, this is just for you. We'll talk a little bit about what some of the options are for the future Burnside Bridge, and then the range of bridge types. We'll also be talking about the evaluation criteria topics that are going to be helping to inform decision-making for the selection of the bridge type for this phase of the process. We'll also let you know what additional outreach is happening and some of the next steps and how you can continue to stay involved and informed. And then we'll get into your questions and answers. So this presentation should take about 30 minutes, and we're going to save the second half of the meeting for your questions and answers. But I think we can go to the next slide. Here we go. So a couple of tips. So you can ask questions at any point during the meeting. Do know that I'm going to be watching those, and Sarah and Laura are also here to be looking at your questions and making sure we're answering as many of them as possible this evening. You can type in the questions whenever you like. Again, you can access that Q&A box by looking at the bottom on my screen. It's at the bottom of my Zoom window. You can pop that open and you can see where you can type in a question. We'll be intending to answer most of these verbally. So you might not see a written response, but I'll be sort of moderating our questions and directing them to our lovely team members that I have present on the webinar this evening. But just know that we'll be holding those questions until we get through the presentation. So if you're typing in some questions and you've got some in your back pocket, go right ahead and put them in the box. Just know that we'll be saving those until we finish up with the presentation. If the video freezes for some reason, the internet can be a finicky thing. You can sign in again the same way that you signed into this meeting. So if we lose you, just know that it is being recorded. You can always catch up on the parts that you missed by checking out the recording later, but you can just log in the same way that you logged into the meeting, and you should be able to rejoin us. So I think with that, I'm going to introduce our panelists this evening. I've got both Mike and Steve. So I'm gonna, maybe Mike, if you can introduce yourself first, and then we'll go over to Steve.
Yeah, hi everyone, Mike Pullen. I work in the Multnomah County Communications Office and working a lot with the public on this Earthquake Ready Burnside Bridge project.
Thanks, Mike. Steve?
Hi everybody, my name is Steve Drahota. I'm with HDR Engineering. I am the technical lead working on behalf of the county, and I've been a bridge engineer for nearly 30 years. So hopefully I can address whatever questions come up later on.
And my name is Allison Brown, and I am a facilitator with JLA Public Involvement, working closely with the team, and I'll be your facilitator stroke moderator this evening. We've also got Sarah and Laura, who are off camera at the moment, but are helping to keep everything together and moving smoothly. So that's our team for this evening. Hey, Sarah. Hello. And they'll also be helping to make sure that we're capturing your questions. As Mike and Steve said, we've got a lot of expertise in the room between the two of our panelists here. But if there is a question that we're not able to answer, we'll be sure to note that and then maybe give you some insight on where and how that question could be answered. But I think we should be able to get through most of them, or at least give you some insight on when that question might be answered. So feel free to lob us some hard ones if you've got them. All right, let's go to the next slide. And I think this is where we get into our project overview. So Mike, this is over to you.
Yeah, thanks so much, Allison. And thank you all for joining us tonight. Steve and I and other members of our team do a lot of what we call road shows, where we go out and talk to different groups. And tonight's really about people who just maybe aren't part of that audience. And we wanted to give the rest of the community a chance to hear our presentation and have an opportunity to ask questions. So I'm going to start with a few slides just to introduce you to the project and why we're doing it. This slide is an important one because it tells us that even though no one who lives in this state today has been through the big one in Oregon, this slide tells us that it's going to happen someday, because as we look at this graph, that's the last 10,000 years of time. Every blue line on that graph is a 9.0 earthquake, which is a really, really big earthquake. And the orange lines are an 8.0 earthquake. Steve and I are from California, earthquake country, and we've both been in some pretty big ones, but nothing even near an 8. So this slide shows that these large, what they're called Cascadia subduction zone earthquakes, they happen regularly in our region, and we haven't had one for 320 years. And since the last one, we've built all our infrastructure. So the risk wasn't really known until maybe around the 1970s or so. So we need to make sure we have a bridge that's ready when the big one strikes. Next slide, please. So why are we doing this project? Engineers tell us that if the big one were to happen today, none of our downtown bridges in Portland would be usable for at least a month. And in the case of some of the bridges, we'd have to completely rebuild them. So that would really devastate the community in the immediate time after the earthquake and really harm its ability to recover. So the purposes of the project is to make sure we have at least one bridge we can count on the day of the big earthquake. And then after that day, we want to have at least one bridge that we can use to recover as a region. Here I oftentimes mention the example of New Orleans. And after Hurricane Katrina, they lost about a third of their population, about a third of their jobs. And I think they're still, 15 or 20 years later, they're still underneath the population when Katrina struck. So we want to have infrastructure that can help our region recover and hold our economy and our jobs here. Then the last point on the slide is if we're lucky and maybe the earthquake doesn't happen in the next 100 years, well, that doesn't change the fact that the Burnside Bridge today is 94 years old. We're not going to get another 100 years out of that bridge. And Multnomah County is interested in making sure that whenever the earthquake happens, we've got a bridge that will serve us another 100 years. And we want a bridge that works well for all modes. And the current bridge doesn't work well for all modes. Next slide, please. So a lot of people ask, why is the Burnside the focus of the county? And it's true that there's other bridges across the Willamette River that carry even more traffic than the Burnside. The freeway bridges come to mind. This map shows the emergency lifeline routes that the region has identified. And this is probably 30 years ago, these lines were identified. And Burnside is the only lifeline route that Multnomah County has a bridge on. And Burnside is shown in yellow on this regional map here. This map shows a lot of red dots, and those red dots are structures that are on these lifeline routes that are actually at risk of collapse. And you see a lot of these red dots are on the freeways. You see the major routes, 205 and I-5. And Burnside, fortunately, does not have a lot of overpasses or things that would fall onto it or that it could fall below. So the Burnside Bridge, if we're able to replace it, it will really make Burnside Road a lot more reliable as an emergency route. And there are a few other structures up in the West Hills that the city of Portland has, and we're working with them. And if we can get the bridge up to date, we would hope that PBOT can help with those smaller projects that are up in the West Hills. So that is why Burnside was chosen. And I should also mention that ODOT has to worry about the whole state. And when they look at the state's seismic preparedness, they look at their options, and they've identified I-205, which is a much newer freeway than I-5, as where they're going to invest their dollars. So that also means that I-5 and the bridges in Portland that are part of I-5 are not in line for getting upgrades anytime in the near future. So meanwhile, we want to make sure downtown and the east side are connected, so we've chosen Burnside. Next slide, please. So we're in a long project. I was talking to a journalist today about how long these projects take, and it is true. There's a lot of requirements. When you build something new, you have to go through additional planning and federal review of your plans. So we are marching from left to right across this slide of our schedule. We've done a feasibility study that looked at every single option you could think of, even tunnels. And from that, we ended up with 4 of the best options to do a deeper level of study on. We're in that phase. We've identified a preferred alternative. We're going to show that to you tonight if you're not familiar with it. And by the end of this year, the end of 2021, we expect to have our plan approved, including the preferred alternative. And then next year, we can begin the work to design it, acquire right of way. That's about a 2.5-year process. So we could be about 3.5 years away from constructing the bridge. Fortunately, we have the money to get through all this design phase, some of the money for construction, and we're looking for the additional construction funds from state and federal sources. One thing before we leave this slide is that there have been some changes in the federal approval process, and one of those changes requires us to actually identify the bridge structure type this year. In the past, you might have been able to wait until after you got your plan approved, but there's new requirements, and that's why we're talking today about what structure type. So we hope to make that decision by July of this year. Next slide, please. So this slide kind of zooms in on the immediate milestones for us. So when it comes to the bridge type, tonight we're going to share with you the ones that we've identified as a small range that kind of are feasible and make sense for being considered in more depth. And we'll be coming out with a recommendation of the preferred bridge type later this spring. We have a community task force that gets deep into the details of these decisions and makes recommendations. So they're expected to make a recommendation. I think it's in May, and we'll go out to the public with that recommendation and then look to finalize it in July. And as I mentioned, or I guess it says June on this slide, but I think it might even stretch into July. And as I mentioned before, once that's approved by the federal government, we can start the design work next year. We hope to hire the design firm and even the construction firm by this fall. Next slide, please. So how much is it going to cost? That is a very important question. We're looking at a range because we don't know which structure type yet, do we? That's still to be determined, but it's in the $800 to $950 million range. We do forecast that in, building in the inflation, which is one reason the number is so high. You look out to the year of construction, and you do have to kind of look into a crystal ball. What will steel cost? What will labor rates be? So that's one reason we don't have a single number. We don't know the structure type, and we're still a long way from getting the bridge designed and built, but that gives you a sense of the range. It's a big dollar project. Next slide, please. So yeah, now we'll give you some visuals about the bridge structure type. I've got a couple slides before I hand it over to Steve. So what are we looking at here? This is a bridge that you'd have to be pretty old to remember. This is the first Burnside Bridge, which served us for about 40 years, I think, built in the late 1800s and lasted until the current bridge was built in the 1920s. So this is a reminder that bridges don't last forever. A lot of people have commented that there's things about the current Burnside Bridge that they like, and we will have to do some mitigation, which means ways that we kind of memorialize the bridge if we are going to replace it, which has been recommended. Next slide, please. So this slide just kind of reminds us of all the bridges that we have along the Willamette River in the city of Portland. It's been called sort of a collection of bridges, a bridge museum. We do have a lot of different types of bridges represented in this small stretch of the city. On the left of this graphic is a little chart that reminds us how tall they are. And that's one reason we are building a new Burnside Bridge with a movable span. We did seriously look at having a bridge that you'd never have to wait for the drawbridge to open. I know a lot of drivers would love to have that. We learned that such a bridge would have to be so high to accommodate ships that visit our city very seldom, that it would touch down around 10th Avenue on each side of the river. So that would be a very expensive bridge and very inconvenient for people that like to get on the bridge near the river. So we dropped that idea and we're looking at a movable structure. Next slide, please. So here are the structure types. It feels like the Academy Awards, our candidates. We've got a tied arch, which would be a little bit like the Fremont Bridge, cable supported, which is a little bit like the Tilikum Crossing, the new TriMet Bridge, and a truss bridge, which is like some of our oldest bridges, like the Hawthorne or the Steel. And then on the movable span, we're really down to just two choices. Bascule is the type of structure, type of drawbridge that the Burnside currently has. The Morrison is another one that's a bascule. And in this kind of bridge, the leaves rotate up, and then you have an unlimited vertical clearance in the center. The other option is a vertical lift, which is similar to the Hawthorne and the Steel bridges. With this one, you do have a finite amount of vertical clearance when it goes up. It can only go up as high as the towers that hold it up. And that's not too big a problem, because if you think about Burnside, just on either side of that bridge, you have the Steel Bridge, which has a finite vertical clearance, and then the Hawthorne Bridge, a couple bridges to the south, also has a finite amount of clearance. So this is a very logical, feasible type of structure that we could build for Burnside. Next slide. So I think this might be my last one before I hand it over to Steve. This is kind of about the parts of the bridge that we're going to decide this year versus the parts of the bridge we're going to decide during design. You see some symbols there for TS, that's type selection. And then there's other things that are FD, that's final design. So this is partly to remind folks who want to get into designing some of the smaller details like lighting, like the overlooks that you might want to have on a bridge like this, so that somebody walking across can step out of the sidewalk and have a nice lookout where you can look down at the river. Those are things we'll decide in the next couple of years, but not this year. This year, we're really deciding on the structure type, such as will it be an arch, or will it be a truss or a cable stay, and what type of movable span we'll have, and then what are the general locations that will have the columns that will go into the river and on land. So just to let you know, that's the kind of decisions we're making this year. And I think, is it the next slide where we hand it over to Steve?
Mike. And so one of the key things about that last slide where I had FD and TS, we're thinking about type selection is really about basic form. And so a lot of the graphics that I get the opportunity to present are representations of basic form. So even all of those cool ideas about inclination of arches, or the style of cable stay, or even the form of a truss and how it works together, a lot of those things would be punted into final design. So as we're looking at this and we're thinking about this nod to the future, there's really this key theme of this bridge, and it's 3 bridges in one. There are some really unique features of each part of the bridge. The left side is, as you can see, downtown Portland on the left-hand side, is the west approach. And it's about 425 feet long. And it's really the span that goes from the in-water pier that's out there to over or around Nadro Parkway. Then you have that center movable span that's about 450 feet long. So comparable lengths, very similar lengths. And again, like Mike described, could be a bascule, could be a lift, a couple different varieties of movable bridge. But on the east side, you have a much longer span, that 650 foot long span. It has to go over more things, not just over the river or the East Bank Esplanade, over the freeway, over the Union Pacific Railroad lines, and then land somewhere before 2nd Avenue. So it's a really different type of opportunity. And so we know that all these parts of the bridges are really just one bridge. And so we have to think about the individual needs of each span and how it all works together. So how do we do that? So we look at a series of these different long span options. So on the left, these are real world examples from across the United States of different kinds of bridges that could represent the graphics you're about to see. So first is the tight arch, and that's a basket handle tight arch on the upper left. So it has those inclined arches. Well, that's one style, but it could be something else, which is something that, if it was selected, would be resolved in final design. The truss in the middle, many people are familiar with trusses around Portland. Truss bridges are one of the key hallmarks of the various movable bridges up and down the river. And so we're looking at a modern version of a truss or a cable stay. This is like the Tillicum Bridge, the cable supported towers with cables that suspend and hold up the bridge deck. And how might that work on one of these approaches? Now, what's unique about this is on the west side, because the west approach is at 425 feet, there's also this opportunity for a girder. And so this is a very modern style of a girder, where the bridge deck, the bridge structure is below the deck. And what it would do is preserve the views above, just like is out there today. And so there's some trade-offs between the different long, thick spans and the girder style. And so that's what we'll show here in a bit. So next slide, please. So when you think about the approaches, it then has to frame into this movable span. And so these are two pretty modern versions of movable spans. I think we're all accustomed to seeing bascules and lifts that are over across the Willamette. Well, these are different forms of the same. Lift on the left, and this is a bridge in Bordeaux, with individual towers that has the span itself lift vertically up between those four different towers. And then the bascule on the right, this is called a delta pier because it's shaped like a triangle. So right in the middle of it, you would have the rotating bridge portion, the bascule bridge, just like is out there today. And we're looking at a style of this delta pier as one way to potentially solve what this bascule option could be. Next slide, please. So as we start looking at these different bridges, the range of bridge type is this tight arch. And so this is a model of the basic form that goes with a tight arch, that curved top arch rib that extends down, similar to the Fremont Bridge, the middle part of the Fremont Bridge, and then connects into some form of movable span. And so on the next slide, we'll start to show, if you're taking a helicopter and imagine flying down the middle of the Willamette River, how could these different tight arch variations look? So in this case, it's with the bascule. And so again, in the closed position, it looks like a flat beam, and then obviously it rotates upwards to allow ships to pass by. So in this top view, you can see that the west span, just like the east span, are different tight arches. They're different heights because you have different span lengths. And so this characteristic of having an equivalent tight arch on either side is really borne out by having a similar shape, but not necessarily the same height. And then on the bottom picture, this is a variation where instead of having a tight arch on the west approach, you replace it with a longer girder style, like I was mentioning earlier. And so what that does is it provides open views above the deck. And so you can see from a view standpoint, a much more open look, but the consequence of that means you have to put a column in Waterfront Park, and then the deck gets thicker, and therefore there's less clearance in Waterfront Park than there even would be today. Less columns, but less vertical clearance. On the next slide, we show what does it mean if you replace that bascule with a lift. And again, just like on that bridge in France, in Bordeaux, France, with those individual towers, this is how this concept could look, where you have these individual towers with a vertical lift in the middle of it. And framing into it are either tight arches on both sides or a tight arch on one side and that girder option on the west, on the downtown side. So different perspectives and variations for how the tight arch could work. And so we did the same thing as we go on to the next slide for a cable supported option. And so in this case, this is comparable to the Tillicum Bridge, and you side that frames into the movable span in the middle. And so this is that view that is to the left. If we go to the next slide, we'll start to see some comparable elevation views. Again, that take that same helicopter ride, assuming a ride down the Willamette River with different cable options and different tower heights because of different lengths, with or without a girder span on the west approach. Allison, is there a question or should I keep going?
There is a question that I think will be wonderfully related to these slides, but I'm going to ask that you keep going.
Okay.
We'll hold questions to the end. You were breaking up a little bit on my end, so I just want to let folks know if anything's breaking up, we're going to try and just recap. But I think folks have got the gist of what Steve was saying. So back over to you.
Okay, very good. All right, and so the prior slide was with the bascule span, again, that rotating span. And so this slide shows with the lift option. So again, those lift towers in the middle with some form of cable support framing into it, or that girder option on the west side. All right, next slide, please. So then we looked at the truss, and the hallmark of the truss, similar to what's out there at many locations across the bridge, is its diagonal members on the outsides, its cross bracing on the top. It's fairly thick members compared to some of the cable supported options or even the tied arch. But the truss is a very viable option. And if we go to the next slide, you can see how you can frame in the trusses on either side to the different bascule options. So on the next slide, there we go. We have that same helicopter view. With the different sizes of truss. Again, because it's longer on the east side, it's taller compared to the west side, with or without that girder option. Again, with that trade-off between having more views above the deck versus having limited vertical clearance below the bridge where Waterfront Park is. All right, next slide. And in this slide, it's really that same idea, but with these vertical lift towers in the middle. Next slide, please. So when you compare the truss and the tied arch, it really comes down to a couple different basic differences. Number one, the truss is relatively shorter than the tied arch, and you can see that through the numbers, whether it's 60 feet or 95 feet compared to 85 or 120. Basically, the tied arch gets a little taller. But what it has working for it, the tied arch has only 3-inch diagonal members, this network arch, versus these 3-foot thick verticals and diagonals on the truss itself. And on the top, subject to how final design goes, there's a chance that you can actually eliminate the bracing at the top of a tied arch through thicker rib members, those arched members. But on truss, it's part and parcel to what a truss is. You need that closure. So they have the same basic vertical clearance, but there's a difference in the openness, the feel of it, depending on what the options are. All right, next slide, please. All right, so now what we've done is we've taken our camera and we've placed you in the middle of Waterfront Park looking south. So you can see on the right-hand side, the Portland, Oregon sign. That's where the U of O building is, adjacent to the bridge. And what you're seeing on this screen is the existing bridge with its series of columns and supports throughout Waterfront Park. And so as we look at these different options, and we'll start with the next slide, please. We'll start with this tied arch. And in this option, the tied arch spans all the way from that pier in the river over to a support, in this case, near NATO Parkway. And so you can see by eliminating all of those columns in Waterfront Park, you really open up the space. In fact, you gain a couple of feet of vertical clearances underneath the bridge as well, just because you've moved the structural portion above the deck. And so the compromise of having some superstructure above the deck means that there's more space below. All right, next slide, please. So as we compare that to a cable supported option, in this case, it's a cable stay, and the tower height can be a variable depending on how thick you want the deck. But in this particular solution, the tower is placed in the middle of Waterfront Park, and the purpose of that is because you want to balance the loads, the weight on either side of the tower. So you generally want to have as close as possible the length of span to the left of the tower as you would to the right of the tower. And so while the tower itself was placed in the park, you still have a greater sense of openness in the existing bridge just because of all the other individual columns that have been removed to allow this vertical clearance to exist. All right, next slide, please. So then we get to the girder option. And the hallmark of the girder option is the open views above. But again, that trade-off is it has to get thick as it goes from the deck level down to where the support is. And this is where the vertical clearance gets reduced. A lot of people really enjoy the views. They enjoy when they walk across the bridge, seeing the Portland, Oregon sign or having an open view into downtown. And so this option provides that kind of a benefit. Again, with that trade-off of what does it mean to the park space below. All right, next slide, please. And so what we've done is created a slide that basically has all of these options all at once to get an easier understanding of the different trade-offs and opportunities that come with the different bridge types. And so some of these, like I was saying before, have more vertical clearance, this 25-foot vertical clearance versus the 23. Some of them have less, the girder option. And so each one of these is being assessed as part of our type selection process, this basic form to understand what bridge type should ultimately be selected. But there's a lot of options. And so on the next slide, we're using a set of criteria to help. How do you actually pick amongst all these different options? And so through the use of an urban design and aesthetics working group, through the use of the community task force, through the engagement of other agencies, the city of Portland in particular, we've really developed a series of different criteria to help assess and make an ultimate recommendation that is really going to be made by the community task force. And so these criteria are really lumped into 3 buckets: human experience and bridge surroundings. Think of this as site context. What is the bridge connecting into and what's around the bridge? You have the overall look and feel of the bridge, which is the bridge itself, the bridge aesthetics itself. And then you have cost and construction impacts to users. So what does the actual project cost in the short term? And what is the cost of it over the long term? And some of them have implications of more maintenance versus some of the others. And so the community task force is being asked to assess all of these different options against these types of criteria, and then ultimately make a recommendation on which bridge type should go forward into final design. And so with that, I will hand it back over to Mike.
Thank you, Steve. So we are hearing a lot from the community about this decision. I think this is a part of a project that people like to kind of sink their teeth into because it's really about appearance, and a lot of people have opinions about what it should look like. So that's why we're getting together with you all tonight. We've been doing a lot of road shows, we call them, where we go out and talk to different groups. We have an online open house that's we recommend. If you haven't been to it, it's up till February 21, and it has information, some of which you've already seen, but even some more things, like we have a video where you can kind of see what these different bridge types might look like in the existing environment of the Burnside Bridge. We're also, so we've had about, I think, over 1,000 people have looked at the video. We're getting close to that with our comments that people have made, and also working a lot with people who have connections to the non-English speaking communities in Portland. It's going well, and it's really a big push the next couple weeks before we wrap that up and then take all that input back to our community task force and let them know what we heard from the public. Next slide, please. So coming up on that, we have our current outreach in January and February. Then we'll go back to our community task force in March, and also update our policy group, which is a group of elected leaders from around the region, about the range of bridge types and the evaluation criteria that Steve just shared with you on that slide. Then the community task force should be making a recommendation here in the spring, and then we'll come out with that recommendation to the public. And hopefully we'll be deciding this July on what type of bridge we're going to design and build. And it's getting more real with each month as these decisions kind of get locked in. So I do see we have a couple questions too. I don't know if there's another slide before we go to
I think
questions.
next up, yeah, it's time for questions. So Laura, I'm going to ask that we keep the slides up just for a second, because this first question from Sean, I think will be helpful if we can maybe go back to slide 20 or somewhere there about. Steve, this is one for you, so get ready. Folks, just if you joined us during that presentation, now is the time for your questions and we will do our best to answer them. So you can chime in using the Q&A box in your Zoom window. On my window, that's at the bottom of the screen. You can click that box and type in a question, and we'll be taking those and doing our best to answer them now. So Steve, this question from Sean, and I'm going to read it out loud, asks, what restrictions are keeping you from having a bent or pier adjacent to I-5 and or the railroad tracks to split the 650-foot span in two?
Great question. In fact, I'm going to have you go back to slide 16. I think there might be a little better view of the area. So I know this was probably a bridge person because they use the term bent, which only us bridge people know what that is. So what that is, that's a support, an intermediate support, a series of columns that support spans on either side. So one of the hallmarks, how did we get to this long span alternative? It's really about the risk to liquefaction and lateral spreading, which is a really technical term that basically means the soil, when the earthquake hits, liquefies, literally turns from solid soil to a mush, a liquid. And so what happens is anything that sits on it settles and flows. There's a slope, that's a hard surface underneath about 110, 120 feet below the bridge. And so there's a tendency for the entire mass of soil to flow towards the river. As we were looking at different options, we actually looked at an option that placed a pier right near the bottom in that space that you can see on the bottom part of the graphic. And the cost to actually mitigate that, build an earthen dam, effectively hold back the soil behind it, was so severe, and the risk of that soil displacing that mitigation was so large, and the potential impacts of doing that mitigation were great. They could affect the columns of the actual I-5 bridges, that the thought was to avoid as much as possible this risk, and therefore extend and move that support as far east as you could go. So we couldn't go as far as we really wanted to. We have some roads we have to land a column in, but by shifting the support like we did to garner the 650-foot span, we're able to minimize that risk of this geotechnical hazard that's below the bridge. So that's the fundamental reason for why we're doing that for this long span option.
Thanks, Steve. I hope that answers your question, Sean. Thanks for chiming in this evening. We have a question from Alex, which I think might be a Mike question. I'm going to read it out loud because there are a couple points here that I think, Alex, I appreciate you putting into this question. So, given that 1, climate change is an existential threat, and 2, gasoline-powered cars are the most persistent and difficult to avoid cause of global warming, and 3, climate change is an existential threat to our society and way of life, I'm wondering what the plans are to eliminate cars from the Burnside Bridge. Mike, thoughts on ways that we could get rid of cars on the bridge, or if that's being taken into consideration?
Well, Alex, thank you for raising that question. It is an existential threat. The Burnside Bridge, our use of it as people changes over the years, and it partly reflects things like climate change, like you're talking about. When I joined the county, I think it had 6 lanes for traffic, then it went down to 5, and now just about a year ago, it went down to 4. So now there is a bus-only lane in the eastbound lane, and it's actually the city of Portland that makes a lot of those decisions. This is sort of a bureaucratic answer to your question, but the city of Portland is the road authority, and ultimately they make these decisions about how the bridge traffic lanes are allocated, and TriMet plays a big part in that. Multnomah County has a lot of experience building bridges and maintaining them, and they're kind of a specialized type of thing. And we have been in that business basically for over 100 years. And we kind of follow what the city wants to do with allocating the traffic lanes. I think watching trends, we've seen that more space is being allocated to bicyclists and pedestrians. We propose greatly expanding the amount of space on the new bridge for bicyclists and pedestrians. We don't add any new traffic lanes, and we're actually factoring in the fact that we could see another bus-only lane in the near future. So it's probably more of a gradual thing as we see single occupancy vehicles decline in number. But that's sort of how I see it happening kind of more gradually.
Thanks, Mike. There is a comment from Joe that asks, what can be done to name the bridge after Mike Pullen?
I told my dad not to do that. No, Joe's a friend from one of our local construction companies. Appreciate his support.
I told you that there may be a moment or two of levity in the meeting. So thank you, Joe, for doing that. Folks, if you are sitting on some questions, please do chime in to the Q&A box. That's our way to hear from you this evening. So get your questions in there. I have a question for Steve. This comes up quite a bit when we talk about the bridge. You talked about the range of bridge types that this project is looking at. And I know that there are some folks in the audience who are really interested and concerned about seismic resiliency. Is there one bridge type that would fare better in an earthquake than another? And can you tell us a little bit more about that?
There are, and the good news is all of those that would not fare well have been screened away. And so what we have left in these remaining options will all equally perform to this really rigorous seismic performance standard, the criteria. So first we'll start with going back to the purpose and need. We expect this bridge to be the one bridge that's available as soon as the earthquake is done. And that's a pretty tall order. That's not what the standard is. Most bridges are designed so that it can take a little bit of damage, and then there's a little bit of an inspection, and then when given the all clear, people can use it. Well, we understand that most of the bridges are highly vulnerable over the river. And even the Tillicum, brand new Tillicum is fantastic, but the approaches are vulnerable for settlement. So we know, and the county's investing in this bridge to be the one place to go when the earthquake happens, the beacon that all people to travel east and west on can get across the bridge. It's going to be the bridge for emergency services. This is also part and parcel to the need for vehicular lanes, because the emergency response vehicles and all of the construction equipment that's going to have to come and really help to restore the community is going to be using this bridge. And so that space in the middle to allow emergency services to coexist with all of the traffic, individuals, bicyclists, pedestrians that are using the bridge, it's really, really important. And so these bridges that we have left, whether it's the tight arch or the cable stay or the truss, are all going to be equally designed to have that same performance criteria. It will be there after the earthquake hits. It will be that lifeline route that everyone can rely on. And so that's one of the reasons why the cost numbers are where they are, because the county understands how important it is to make sure that this one bridge is the bridge that everyone can congregate at and go across.
Thanks, Steve. And looks like that was Rob's question. So thanks, Rob, for joining us from City Club. And again, folks, if you have more questions, get them into that Q&A box. Mike, I've got a question for you. And I know Pam is in the audience, who is a former bridge operator. So thanks for joining us, Pam. But, you know, a lot of people really have a lot of love for the existing Burnside Bridge, especially some of the historic features that are on the bridge. Is there anything that can be done, or is the county thinking about ways that some of those elements could be preserved, even with this new bridge?
Great question. When a bridge is like the Burnside and it's actually considered on the National Historic Register of Places as significant, I think the designer of the bridge was a pretty famous bridge engineer, and it's beloved by a lot of people in our community. We have to do certain things if we're going to take it down. One of those things is you make its historic significant parts, available for reuse. That has happened in the past. When it comes to the Burnside Bridge, we hear a lot from people that really love those operator towers. So we will look at, is there a way to salvage one or both of those to reuse them somewhere? Things like the historic railing, maybe even some of the things that people don't typically see, like the amazingly large gears inside the drawbridge that help it open and close. So, we'll seriously look at what can be salvaged repurposed. I think it would be really hard. We've heard some suggestions. So is there a way to save some of that and put it in the new bridge? And I think practically that may not be the way you want to go, but at least look at saving parts that are really meaningful to people. There's some similar things we've done. There were parts of the Broadway Bridge that were over 100 years old that we've saved and are looking for maybe a property around the Broadway Bridge where we can show them off.
Mike. Steve, were you going to add into that?
Yeah, if you don't mind. So one is I have the Historic American Engineering Record, the Hare Report, written by some friends of the bridge. The bridge is an awesome structure. I mean, it flat out is. It's 94 years old. It's perfect for what it was designed and intended to do back in the 1920s. Unfortunately, in the 1920s, seismic wasn't even conceptualized for this area. And so it has many, many, many vulnerabilities and weaknesses that just weren't ever designed into the bridge. And it starts at the foundation level. Those individual piers in the river are founded on a series of, frankly, telephone poles. In this liquefiable soil, even in the river, the concrete itself doesn't really have the reinforcing like you would typically have that can withstand an earthquake. The piers themselves are vulnerable. Even the mechanical electrical equipment is still the same mechanical electrical equipment that was built back in the 1920s. I mean, it's a wonderful, awesome bridge. Unfortunately, never designed for seismic. And even the extended parts, the approach structures, have these same vulnerabilities. So we did a pretty exhaustive analysis, seismic retrofit analysis, to say, can we save it? And the answer was, unfortunately, it takes a monumental, almost Herculean effort to do it, whereas the costs are on par, equivalent, maybe actually a little bit more than replacing the bridge. So we're looking at, just like Mike was saying, ways to preserve some of these other key components outside the project. Maybe there's a place on the East Bank Esplanade along the walkway. Or maybe there's a way to look at the railings and take some of the gears and embed them into the rail. There's a number of mitigation items that we're looking at to not just report the history of it, but actually keep some of the elements in it. So I'm looking forward to seeing how that plays out during final design.
Thanks, Steve and Mike. We've got a question from Joe, which might be difficult for you two to answer. So I'm going to also tack on a second question with Joe's question here. Joe's asking, is there a preferred bridge type of the alternatives that you've proposed this evening? And Steve, I think this is more for you. I think a question that often comes along with that is, which one is actually the cheapest and which one is the most expensive? So you can tell us if you have a favorite of all of your children and maybe how much these alternatives cost.
That was literally the analogy that I was going to be asked. Pick my favorite child. Well, luckily I only have one, so it's an easy question for me in general. It's harder on this bridge. There are attributes of every one of the bridge options that remain that I really like. I personally don't have a favorite. Like I said, there are some elements to each one that I think are really, really awesome. And luckily, I don't have to pick. My job is to help communicate all the facts and then convey the different impacts so the community task force can make a recommendation. And that's through that different criteria. So it's a bit of a cop-out, I know, but generally speaking, I would be happy and honored to be able to design any one of them. Maybe the trust is slightly less. I might prefer this compared to the others, just because of the views. But that's consistent with a lot of the feedback we've gotten already. From a cost standpoint, we're still in the midst of analyzing the individual alternatives for cost. There's a number of different risks that go with each one. Within the next 2 months, we'll be able to report out how much does each of these individual costs come out as, and it's within that cost graphic that Mike showed earlier, where it's within that range. So more to come on that. I wish I had that detail right now, but not quite yet. So hang with us, everybody. Over the next 2 months, that information should be available.
And it sounds like that the community task force would have some of that information before they make their recommendation. Yeah.
Thanks. We have a question here that is about evaluation criteria. And I think we could also maybe dig a little bit deeper into the evaluation criteria. And an anonymous attendee asks, with an enhanced seismic criteria being considered, will the typical AASHTO service life design criteria be enhanced also? And if so, what service life duration is being considered? I did do a quick Google, and I believe that the acronym is the American Association of State Highway and Transportation Officials. So maybe Steve or Mike, you can illuminate those of us who are not so clear on the state highway service life design criteria, kind of what that is and how that affects this project.
Luckily, I'm very familiar with the AASHTO criteria. AASHTO is one of these federal guidelines that is universally used to design bridges. There's a number of different guide books and guidelines that sort of augment it, but it serves as the platform to get uniform design across the entire country so that everyone can feel confident as they're crossing any bridge. The basic answer is we're designing this for a 100-year service life, and that's greater than the standard 75-year service life that is typically used. It's codified in AASHTO and other codes. We are taking service life seriously, and as part, if you want to, well, we won't go to, but part of the evaluation criteria in that cost and construction is this long-term cost issue, and how do each of the bridges relate or reduce these maintenance, inspection, and other, we'll call it life cycle costs, sustainability costs that come with each one. Some of those are easy to assess in this early stage. Some of them, like the cost to climate, is harder because it depends a lot on materiality, exactly how much steel, how much concrete, where is it going to go, part of that. So we're deferring that part of the discussion until final design. But from a life cycle standpoint, building in an ease of maintenance and an ease of operation is part and parcel to the different alternatives we'll be looking at and built into the criteria itself.
So Steve, maybe we can continue on that line of criteria. One thing that's been really important to, I think if folks have tuned into the community task force meetings, is looking at sustainability and environmental impacts. And when we look at the criteria that you noted earlier in the presentation, that isn't specifically called out. So how are environmental impacts being considered in the criteria for the selection of the bridge type?
I'll answer that first, and then I'll get to some other ones that are noticeably absent that are very important values to both the county and the community. So in a lot of ways, this long span alternative has very similar levels of impacts to the environment. In fact, so much so that when we went through and said, okay, this key interest, this key driver, this value of environmental impacts is so important, how would each of the different alternatives fare? And it turned out that they basically were the same level of impact. And so instead of building something into the evaluation criteria that is going to get its same score across the board and not differentiate, we said, you know what, let's take that off to the side. We understand that it doesn't differentiate, and then use that, defer that detail into the final design as some of the other details around final design are being made. So it's an incredibly important value. It's not differentiating, and therefore it wasn't put into these criteria. Another one that's like that, and in fact, on the slide, it says pedestrian and bicycle connectivity, TBD, may not differentiate. And so the reason why we said that is when you think of what's on the bridge, we're looking at the same cross-section. So the same number of lanes, the same widths across all the different options. And so it doesn't differentiate when you're on the bridge. Then you look below and you say, okay, so how are bicycles and pedestrians affected on either side of the bridge based on the bridge types? And lo and behold, they basically came out to be the same. So we're still hunting to see if there's some meaningful differentiation for bicycle pedestrian impacts that we haven't already seen. And if there isn't, well, then that one will be taken off the list of differentiating criteria, still put into this really important bucket of needs to be resolved during final design. But it doesn't seem to serve as a great criteria to pick amongst the different bridge types.
Thanks, Steve. Okay, Laura, this might be helpful if we pull up some slides, because we have a question that I've also thought about quite a bit. Why are the structures on the approach spans different sizes? And could they be made to look the same? So maybe we can take a look at this, and you can help us. If folks are not super familiar with what approach spans might mean, you can refresh our memories on what we're looking at.
Maybe while she's pulling that up, maybe I'll give a little insight into this. I think there's a slide that we oftentimes show that we didn't include tonight that shows the band of the liquefiable soil on each side of the river. And that's really the explanation to this question. That band of liquefiable soil on the east side is much wider. So it's from the river's edge to around 2nd Avenue, which is about 3 blocks wide. And then on the west side, it's only like 50 to 75 feet wide, right along the edge of the waterfront park where the seawall is. And that's really why you notice where the piers come down, it's much farther from the riverbank on the east side, and hence that longer span needs a taller structure to hold it up. It kind of gets, I think Steve was addressing that when he was answering a question about why don't you put some intermediary span on the east side that's kind of more between where the freeway lanes are. And it's because that's sitting on liquefiable soil. And I guess the reason for that is there's a bend in the river at this point, and on the outside of that bend is the east side. And it's just, the river's just been dumping sediment there as it flows through this point for thousands of years. And on the inside of the curve, there's a lot less.
Yes, okay. Go ahead, Steve.
Yeah, so let's go back to bridge engineering fundamentals. So one of them is the longer the bridge is, the deeper or taller the bridge deck, or in this case, towers have to be. And so to Mike's point, because this span length, going back to the 650 feet is longer, the tower needs to be much taller. And so on the west side, so that's on the east side. The west side, the span length at 200 feet shorter, you don't need the same tower height. And so it's almost looks like kind of a baby cable stay. Now the truth is, how do you make the two the same? Well, you'd have to bring it up the west side and reduce the east side. Well, the consequence of that means now the deck on the east side has to get a lot thicker to carry some of that load. And on the west side, you're basically building in more structure than is really needed from an economic standpoint. So is there a way to make them look more similar? The answer is yes, but really it's going to be very, very difficult to make them look the exact same. And if you go back 2 slides, I think the tight arch does a little better, or I'm sorry, yeah, the tight arch does a little better job, you're perfect, of seeing how they can be similar. And so again, think of by a longer length means a taller arch, and therefore that 650 feet on one side and 425 feet on the other side really does drive the different heights. And so can you, even on this case, artificially increase the height on the west side? You could, but now you have a different inclination angle and your eye would notice that. So the height might be the same, but the way the angle comes down, you would see it and it actually looks awkward. So what we in the bridge engineering world knows that it's better to have a uniform shape and aspect ratio, meaning height to length and those angles coming in, than it is to have the same height. So there's a couple of different variables that are still, could be worked out in final design about where is the pier on the far east side. Maybe it can be scooted in a little bit to make these ratios a little closer, but it's kind of part and parcel of the fact that you have different span lengths on both sides.
Steve, there's a follow-up question that just came through to this, and it's asking, if you eliminated cars and made the bridge pedestrian and bicycle only, would it be possible to use less material and make both sides look the same?
Well, you would make the bridge narrower. If it, anytime you reduce the width, you make it narrower and therefore you use less materials. That is a fact. The same principle exists though on where the supports are, regardless of what is being loaded. It's a function of length, gravity and length. So, are there ways to adjust it slightly? There could be. But generally speaking, that reduction, that elimination would not change this sort of composition.
Thanks, Steve. Okay, and they're clarifying, no, same width, but for for pedestrians and bikes only. So I think just interested in if what the bridge was bearing itself, or the weight that it was bearing, would that change things?
It can. Interestingly enough, loading for pedestrians and bikes is pretty heavy. It's not the same as a massive vehicle, not the same as a truck, not the same as streetcar, which is what this is also being designed for. But it could change that aspect ratio a little bit.
Thanks, Steve. We'll take a couple more questions if folks have them. We are closing in on 6 o'clock, but we are willing to stick around for some longer time. But one thing that I think we hear pretty consistently, you shared some numbers that are, as far as what this could cost, that are pretty high. How is this project being funded?
Maybe I'll take that one. Right now, by Multnomah County residents. If you live in Multnomah County and you own a motor vehicle, you're helping to pay for our current planning phase. That same single source of money will also pay for all the design phase and the acquisition of property that we need to construct the bridge, including temporary access. We have that same source will also pay for some of the construction. We don't know exactly what percentage because we haven't set the budget yet for the total project. So we have money for the next 3 years or so, and in order to get it built, we'll need more money. And we're hoping that the Biden administration will have a big infrastructure bill. We're working hard to get in line for money. Our county chair was actually in a conference call with the new transportation secretary, Pete Buttigieg, recently, and reminded him of our project out here in Portland. So we'll need some outside help, but a trend, those of you in the transportation world might have heard this before, the state and federal governments like to see the locals put their own money in the project early on, show we're serious. So we've really done that as a community, as a region, and they like to be the last money in, as they say. So by the time we get that money, we'll have a plan and a design. So we're working hard to get the rest of the money.
Thanks, Mike, for that. I am not seeing any questions from our attendees, and it is the close of what we had promised to be our formal meeting time. So I think we're going to start to wrap things up here. We'll maybe stay on the line. We'll stop recording and stop our live streaming shortly, but stay on the line if anybody has any burning questions that they'd like to share with the team, or just, pick Mike's brain about any of the fun topics that you might have heard in our pre-meeting banter. But folks, just want to thank everybody who attended the meeting today. Thank you so much for your time, for your energy, for your interest, and joining us today. As Mike mentioned, there is an online open house and survey. So do check out the project website, and you can continue to give not only your questions, but your feedback, and weigh in on which of the types you're liking and what's responding to your read of this information. So do check out the project website. Keep your eyes open for more opportunities to learn more about the project by checking out the website. And maybe actually, Laura, if we can put that final slide, I think we've got the website up for folks to visit and check things out. So it's burnsidebridge.org. And that'll link you up to all the good things that are coming up, and also the survey that's currently underway for a few more weeks. So definitely spread the word. Go join in on the survey if you haven't already, and share it with your friends and families and neighbors and whoever else you think might be interested in the future of the Burnside Bridge. I do want to thank Mike and Steve, Sarah and Laura for your expertise this evening and keeping our webinar smooth and flowing. We've got, I think, some final questions here. So maybe we will let folks, if they want to go on their way and continue with their evening, you can continue on, and we will make sure that any final questions are recapped for you. But I did get a question in that asks, was there any thought to making the west approach span longer with the abutment closer to the max tracks? This could balance the spans. So kind of some real interest still in that sense of symmetry and balance over the bridge. Steve, you want to take this one?
I will. In fact, that's how we originally were thinking of placing the west abutment. So right now, the west abutment extends beyond, on the top of the bridge, about halfway through the Portland Rescue Mission, if you can think of kind of where that is. So you have the U of O retail space that's below the bridge, and then you have a gap even behind that before you reach the end of the bridge or the abutment. What we found is that by moving the abutment further back, it actually created a lot of impacts and challenges to Portland Rescue Mission. It would have closed their services for a number of months. And when we realized that, we're like, oh, wow, that's a significant impact. And instead, let's adjust the abutment closer to where the tracks are to keep Portland Rescue Mission open full-time during construction. So that was a major modification that we made. Now, as it relates to the balancing of the spans, that far portion on the west side of the bridge is really not part of the tall spans that you are looking at. There is, once you get over NATO Parkway, it goes to more conventional girders, kind of like what's out there today, just less columns. And so it changes one of the spans, but it doesn't change the overall look of the longer spans that you were looking at. So we considered it a pretty significant victory to be able to keep Portland Rescue Mission open. That was a meaningful modification that we were able to have, and we're pretty proud of being able to find a way to keep them open and provide that service during construction.
Thanks, Steve. Brad, I'm not sure if that's a question or if maybe part of it got left off, but if we do have any final questions from folks, we'd be happy to stay on the line a little longer and take them from you. And otherwise, it's been a great evening. So maybe have a couple more minutes. We might hold a little bit of awkward silence, or we just look at each other for a few minutes and make sure that there aren't any final questions coming in.
We're also willing to take surfing questions if everybody wants to ask that, or Mike can talk about his cruise experiences. So anyway.
The coldest water you've ever surfed in, I think Allison might have that honor.
Yeah, north coast of Northern Ireland was pretty cold. I think that's also getting into topics that are for our potential upcoming podcast. So
yeah, we might take this on the road.
Different kind of road show.
Yep. Well, I want to thank everybody also who's still with us tonight for joining us. I think the first webinar we've done at Multnomah County Transportation, and it's somewhat because of the pandemic, but it's another good example of just being able to stay at home and participate. So appreciate everybody who gave us an hour of their time.
Yeah. Okay, we've got some requests, Brad, for us to reach out. And Pam says she loved the presentation. Thanks, Pam, and thanks for joining us. It's good to have a former bridge operator in the room. All right, folks. I'm not seeing any other questions. So I think with that, we will close for the evening. Do get in touch via the website if you weren't able to share a question tonight, or you'd like to find out more. Also do take that survey and check out the online open house and the videos that are on there. There's some very cool video features happening. We will be in touch soon. Stay safe, have a wonderful evening, and thank you so much for joining us to learn more about the future of the Burnside Bridge. Really appreciate your time, and we'll see you next time.